Good morning, mathematicians. Today we're going to be looking at multiplying by 9. And some of you know tricks on your fingers and other things, which is great. That's a great strategy. But one of the ones that I like to point out is to know the 9s if you haven't memorized them. I just like to write them out real quick so I have them as a reference. And because I'm going to write them vertically, I'm going to do it on a separate paper, but you might be able to squeeze it in. In fact, let me see if I can let's squeeze it in if we can, okay? So we're going to start with 0, 9, all right? And now what we're going to do is we're going to write from 0 all the way down to 9, okay? So 0, 1, 2, 3, 4. I knew I wasn't going to be able to squeeze it in. 5, 6, 7, 8, 9. Dang, I was hoping I could fit that in. Okay. And then you can count down from 9, or you can start the process again and just go 0, 1, 2. It's up to you. I like to just do it this way. So I'll put the 0 here, and then we go 1, 2, 3, 4, 5, 6, 7, 8, and then we already had the 9. There's another thing that I want to point out to you. So for the 9s, at least up to 9 times 10, I don't know about, 9 times like 27 if this works. I haven't tried that out actually. But if you take the two numbers, we've talked about distributive in the past, where you take two add-ins, right? So if we take both of these digits and we add them together, it should equal 9 no matter which one you do. And that's a great way to know if you've multiplied correctly. So 0 plus 9 is 9. Right? 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 3 is 9. 7 plus 2 is 9. 8 plus 1 is 9. And 0 plus 9. Sorry, 9 plus 0 is 9. Okay, that one looks real bad. You're just going to have to pretend that said 9 plus 0. Now you might be saying, what is going on here? This is it's just a little trick so you can check. So for example, let's say you thought the answer was 63. If 6 plus 3 equals 9, then you know you've multiplied that 9 correctly. Okay, so that's just something I wanted to point out. Some people use their fingers. You can do it a lot of different ways, but we're going to use different strategies to figure this out. Now, as always, I like to look at pictures first. And so I can see that we have some planets here. We have Saturn, we have Jupiter. I believe this is Mars, the red planet, right? Earth, and this is probably Venus, right? So what are you asked to find? I have no idea yet. I haven't read over here. And then it says how many students are making models. So I know that I'm going to have to write a number and then the word students. This I do know. So let's go ahead and look at this problem here. Olivia's class is studying the solar system. Great. That matches the picture. Because there's nothing really, no numbers in here, I'm done with that sentence. I don't actually need to really worry about this sentence anymore. And so now I have less sentences to worry about. I do see a number here that says 7. So in my head, I'm going to keep that number 7. I'll even circle it if I need to. 7 students are making models of the solar system. There is a number here, so I don't want to get rid of that. Each model has 9 spheres, okay? 8 for the planets and 1 for Pluto, a dwarf planet. This is great here, and you might be saying, but that has a number here. They are just explaining this 9 spheres, but I'm not going to cross anything off yet. How many spheres do the 7 students need for all the models? Okay, so what we're saying here is this 7 students is where this number comes from. And the 9 is where this number comes from. Well, because we already wrote the number line out, usually I write them like this direction, but because we wrote it this way, we can just count down 7 of them, right? 1, 2, 3, 4, 5, 6, 7, right? So 7 nines is going to be 63. So I'm going to keep that in my head because I don't have anywhere to write down the number 63 yet. I can even put, if I want, like a little star next to it or something so I don't forget. What are we being asked to find? We're being asked to find how many spheres do the students need in all. Okay, so we need to find out all spheres. How many students are making models? Well, that is a complete search and find. It says right here that 7 students are making models. That's exactly from here, right? The only thing is here they say how many. In this one, they say the word 7. So really, if you look at it, you could replace this word and say 7 students are making models. Okay, so we know that's just a search and find. That's right there. So I can actually just put 7 or 7 students. And now we're going to come down to where we're actually going to start solving it, and we're going to use distributive, my favorite. So what that means is you're going to take one of the numbers and separate them. Now, because we already kind of did this, I think we should separate the 9, not the 7. You certainly could separate the 7 if you like, but because I've already done the work of separating out the second number, I think I'm going to stick with that. Let's see if they did it too. Yes, they also did it that way. So they kept the first number 7. You can see that the 7 never changes, but the 9 changes to other options, doesn't it? And they specifically did 3 and 6, right? So they specifically did this one, but you could choose a different one if you like, but in this problem, they're expecting you to do 3 and 6, okay? So when you look at this, when you separate out this number, the only reason you do that is to help you if a number is really big, right? If you don't know 7 times 9 is 63 by the snap of your hand, yeah, then that's a problem, right? Then you might want to look at this in that way. If you know it like this, yeah, distributive is not really going to be something you need unless it's like bigger numbers, right? But so what we're going to do is we're going to not change. So basically we're saying here, okay, we have the number 9, okay? And if we were to draw it, I'm going to draw it out here. So I need 7, 1, 2, 3, 4, 5, 6, 7. Okay, and in each one I need 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Barely fit that in. And now that you have the first one lined up, you can just fill them in how you like. It really doesn't matter. I would not suggest going in a bunch of different directions because you could mess one up. Also be careful because if you look at mine, mine's getting off a little bit. So I need to be a little bit more careful. And I'm going to draw an imaginary line in between to help me get back on track. And so in this case, it may have been better to just draw them straight down than going across. Because mine did get off just a little bit. Ooh, am I off? I think it's like this. So if I were to take a piece of paper, I can see that I have 7 there, right? And if I took the paper here, I could see that I have 7 there, and 7 here, and 7 there. It does get a little bit off. That's okay though. So that's the one that was really off, yeah? But I can see that these are fairly lined up okay, right? All right. So now what they're saying is they're going to take this big array, right? That if you don't know 7 times 9, that you would have to count this out to get 63. This is actually how I would have chosen to split it up, the 6 and the 3, just because our answer is 63. But they chose to do 3 and 6 first, which is fine. So what we're saying is we're going to split this big thing up. The number 7 isn't changing. So that means that if the second number changes, you split it going up and down. If the first number changes, you split it going side to side. Because rows always come first and then columns. Okay. So, can I pause? Hang on one second. Okay, so we're going to go ahead and separate this because they separated 3 and 6 in the book. That's what I'm also going to do. And so this means I have to go over 3 columns. Remember, columns go up and down. Columns are things that you can stack. Rows are things that you sit in. Like if you go to a movie theater, you sit side by side, right? So you don't sit on top of each other, hopefully. So we'll go 1, 2, 3, and we'll make a split. So what they're showing me is that there are 7 3s on this side and 7 6s on this side. And that's essentially what this is telling me, that I'm going to have 7 3s. So I'm going to have 7 3s. That's what that would look like. Oops, you can't see it, but 7 3s looks like this. And then the 7 6s look like this. Okay? And I still honestly think counting out 7 6s is a lot. Like I probably would have split this differently in all honesty, because that is a lot. So 7 3s, if you want, you can count them up. You could say 7 plus 7 plus 7, or you could do 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3, or you could count them. Really, it doesn't matter. You can do it however you like, but you should get a total of 21 X's on this side, right? And if you were to count over here, you could count by 6s, you could count by 7s. You already know that 7 3s is 21, and then you have another, so you could have 21 here and 21 here and put them together. That would be something you could do, because remember how we learned about 6s and doubling and how you can split? So that could be another option. But if you were to count that all up, you should get 42. So total, you have 21 X's on this side and you have 42 X's on this side, and all together, that should give you a total of, and we already knew this, 63, right? Because we had said it was 63, and we just want to make sure that whatever we said it was, that it matches up. Because if we're either wrong in our initial thought or we're wrong in our counting, but the two should match up. So I feel confident that we've done this correctly. Now what we're going to do is fill things in. So it says, think that 9 is the same as 3 plus 6. Okay, we did that. And that was when we did here, right? 3 plus 6. So we did that. Okay. Multiply each addend by 7. So we multiply the 3 pieces by 7. We multiply the 6 pieces by 7. And so now, remember, this over here, whenever you see this equal sign, you are trying to get both sides to equal the same amount, right? So if this equals 63, you need this side to equal 63, right? And so they're going to show you that by separating things out, you can get it to equal 63. So 7 3s we already know is 21, and 7 6s is 42. And together this makes 63. This here in writing is this picture here, right? Minus that part. It's just that same picture. Okay, so now it says with multiplication and subtraction. Ooh, okay. Ooh, let's put here that we're going to do it with times, and we're going to do it with minus. And I always put a circle around my minus. I just always have, it just helps me. This time, we're not distributing it out in the sense where we find 2 addends, 2 numbers that add to 9. We're going to think of it in a way that's a little bit easier. Counting by tens is super simple. And so for some people, what they like to do is count it out by tens and then just take one group back. And that's essentially what this means. Because if you think about it, 9 is one group less than 10. It's one group less. This means that you could do it by 10, which is easy because you can just add the 0 and then you take a group of 7 back. You could do it that way. Okay, so this is what's happening here. So we know that 7 nines, we already know the answer is 63. When we're solving this through, if we don't get 63 as our final answer, we've made a mistake, right? And this is why it's so important to know ahead of time what you think the answer is, or to like have an inkling, or to do that pre-work, because it's going to really help you out. So what they're showing here, again, there is no change happening here. And we have to get this side over here to equal 63. So the first thing they want us to do is to think of 9 as really 10 minus 1, because 10 minus 1 is 9. I agree with that. 10 minus 1 is 9. So what they've done is they've shown you that 9 is the same thing as 10 minus 1. If you were to solve 10 minus 1, you would get 9. Now that we know the two parts that we're going to work with, we're going to do each part by 7. Because remember, our original thing was 7 times 9. So in here, 7 times 10 minus 7 times 1. Because remember, 10 minus 1 is 9. So we're trying to do something that's a little bit easier to work with, because in all honesty, 7 sixes is not that easy to work with. So this might be easier for some of you. And this is what I do when I'm doing mental math. If I can multiply it by 10 and then just take the group back, I do that. That's something I've just always done to make myself life easier. So you have to, if you make a change to one of the numbers, you have to make it to the other. So that's what we did, right? So in here, 7 tens, if we were to count that out, 10, 20, 30, 40, 50, 60, 70, 80, 90. Oh, I went too many, didn't I? 10, 20, 30, 40, 50, 60, 70. Yeah, so 7 tens is the same as 70. And 7 ones is obviously 7. So 70 minus 7, we already know it's 63. Good. So 7 students need 63 spheres for all the models. Yeah? Okay, so now let's take a look at the back page here. And this is just like we already did, you guys. Look, when we wrote the numbers here, we already did it. So we actually already have all of our answers, and we know 7 nines is 63. We just solved that twice. So now if you don't know the next one, you can come back here and look. The next one was 72, then 81, then 90. But we only have to go to 81. Okay? And for those of you that love numbers, this is called a square root. Okay? So the square root of 81 is 9. 9 squared is 81, in case anybody wanted to know that. Okay. So this is filled in easily. Now what we're going to do is it talks about using patterns, and that's this, right? So you can pretend there's a 0 there if you like. 0 plus 9 is 9, 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9. Say it with me, 5 plus 4 is 9, 6 plus 3 is 9, 7 plus 2 is 9, and 8 plus 1 is 9. Okay, so it says the table shows the 9 facts. I agree. So I can mark that off because I agree. I looked over here. I agree with it. What do you notice about the tens digit in the product? Wait a minute. Tens digit. I have to understand what a tens digit is, don't I? Well, a tens digit is always the second number in place value. So like 45 is the 4 is in the tens digit, right? 37, the 3 is in the tens digit, and so on. In fact, let me just make it the same numbers as over here. I'm going to change it to 36. I'm not going to fill them all in. So what I know is that it's always the second number. Well, this one doesn't have one, and usually in math, when they leave something out, it's usually worth like a 0. So what I notice in the tens digit, remember, I'm not looking at the ones digit. I'm looking at the second number. All of these are called double-digit numbers. And so I'm looking at this. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, let's take a look at something. This here says the tens digit is blank less than the factor that is multiplied by 9. Wait a minute. All of these are called factors. Do you see how it says factors here? And all of them are multiplied by 9. So that is no help. Let's take a look at this. This factor is 1, and we have a 0 here. This factor is 2, and we have a 1. 3 has a 2. 4 has a 3. So they are all 1 less, right? This is a 7, and in the tens digit we have a 6. This is an 8, and this one has a 7. So I am very confident that it is 1 less than the factor that is multiplied by 9. What do you notice about the sum of the digits? We did this. The sum of the digits, 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 8, they all add to 9. So we did that pre-work, and boom, here it is. So what do you notice about the sum of the digits and the product? The sum of the digits and the product is always equal to 9. It always equals 9. Right? We did that already. 6 plus 3 is 9. 7 plus 2 is 9. They're always going to equal 9. So when you multiply 7 times 9, think that the 10 digit is 6, because the tens digit is always 1 less than that factor. And the ones digit is going to have to be 3, because 6 plus 3 is 9. So the product is 63. And that's actually another favorite trick of mine that I use. Okay. So we're at 22 minutes, and I am going to go a little bit long today because we do not have regular math class. We have a special Zoom today. If you are watching this and you are not in my third grade classroom, this does not pertain to you. But I thought, I don't need to go over these with you. These you can just try on your own. I highly suggest that you try this. Remember, you also have this cheat sheet up here. If I see something down here that says 5 9s, well, I can look right up here and find the answer. So you really don't need me for these here, okay? But I thought I would take a look at this with you guys, because this is something that I don't know how much we've shown you before. And so I think this might be beneficial to you. Again, you've got a cheat sheet right here with all your answers. So when you see a circle, it means that you're doing a comparison. So is this side bigger, equal, or less than this side? So you have to actually solve them both before you can make that decision. And so I'm going to write in all the answers, okay? Not for all of them, but for some of them, and then you can try some on your own. So 2 9s, we know that 2 9s is 18. So underneath here, I'm just going to write 18. And ooh, this time it says 3 6s. I don't have 3 6s on here. So I actually have to figure that one out. Let me do all the 9 ones first, just so we have those. So 5 9s we know is 45. Oh, we've done 6 7s before. We did 6 7s here. Do you remember? 6 7s. We did that one. We also wrote it down in our book. Here, we wrote down that 6 7s is 42. So that one I actually already knew. Yeah. Then we have here 1 9. So 1 9 is 9. Okay, we want 9 4s. Well, I don't see 9 4s, but I see 4 9s, so we can do that. So 4 9s is 36, or 9 4s is 36. 9 zeros. If you have 9 of nothing, you have nothing plus nothing plus nothing plus nothing. You have nothing. So we'll put 0 there. And then the last one says 3 9s or 9 3s, and that one is 27. Okay. So I will do a couple with you, and you'll have to figure out. I'll leave some of the easier ones for you. But the first one that I already have done is this one here. So when I ask myself, is 45 worth more or less than 42? If you have 45 of something, do you have more, the same, or less than somebody that has 42? So for more, remember the smaller number always eats the lower number. The lower number always eats the bigger number, I should say. So 45 is greater than 42. That's how you say that. Okay. Let's do another one. I'll do 7 5s with you because I feel like that might be a little bit harder for some of you. So let's count it out. I'm just going to count 7 5s. 5, 10, 15, 20, 25, 30, 35. Okay. Ooh, that one was close. But 35 is smaller than 36. Okay, so we go like that, yeah? And then we'll do 5 8s, which we have done 5 8s before. We've done that number. If you think back to our lesson on 4.8, we did that one. So if you remember, I don't suggest that you search through books like pages trying to find something. It'd be far easier just to count it up. But if you remember, like, oh, I remember that problem was on this page, you can just scroll back and look to it, right? So 40 legs is that one. And if we look at this, wow, 40 is much bigger than 27. Wow, so far all of them have gone that way, but that does not mean that they're all going to be greater than, okay? So let me do one more that has a different one. And let's do this one here, 3 3s. 3, 6, 9. These are exactly the same. 9 is equal to 9. So that would be there. And then remember, if the first number is less than the second number, then it goes this direction. It kind of looks like an L a little bit. That's how I always remember it. Okay, if you would like to try these on your own, you certainly may. I am not going to go through them because we're already pretty long today, but you certainly could try any of those. What I would like you to do for me today for this is we're going to do all of them. I know you might be thinking that's a lot, but really, if you have your little sheet here, it should go pretty quickly. If you are looking at this page, it should go pretty quickly. If you are even looking at what we made here, it should go pretty quickly. I suggest that you identify the ones that are the same first. So look for 2 9s or 9 2s. So you look through, see if you see that anywhere else. I don't happen to on that one, of course not. Oh, I do see one, 2 9s and 2 9s. So right there, you already get 2 of them answered at the same time, okay? And so I want you to do all of them. I'll fill this one in for you. It's 18. 18. The other thing that you can do to help you out is if we're multiplying everything by 9, right? Then remember the easiest way is that it's 1 less and then it adds to 9. So what I mean by that is if you're multiplying by 9, the answer is always 1 less than the other factor, and then you add to 9, so 3 plus 6. Okay, so that's another way you can do it. All right, and then let's look. I want to talk to you guys about, let's do one of these together, and then you have to do the other one on your own. There are 9 positions on the softball team. There's a number here, so I'm not going to mark this off, but I do have a feeling that I'm going to be multiplying by 9. 3 people are trying out for each position. So position 1 has 3 people, position 2 has 3 people, position 3 has 3 people until you've done all 9 positions. So basically, we had that 3 people are trying out for 9 different positions. Or we could have done, actually, I'm starting to think it should have been 9 3s. There are 9 positions. Yeah, you could write it either way, I guess. I think 9 threes is actually the better choice. And so it says how many people. So when you do this, you should write 27 people. Like that, okay? And then on the back side, what you're going to do is I would like you to do number 2. I would like you to do number 3. I'd like you to do number 4. And let's do 5, okay? So I am assigning a lot to you guys today. I am fully aware, but there's no math live lesson today as we have discussed, and I really want you guys to practice this. So it is a lot, but it is what I am expecting, and I thank you for coming to our math video today, and we will see you guys soon. Bye.